Hi everyone, my name is Dmitry Gavrilkoff and you are watching the presentation of my final project called Small Classifier. The project is done for the Introduction to Deep Learning course at Harvard Summer School in summer 2022. As a data science student who is currently working in the healthcare sector, I'm always keen to apply my learnings for the public good. That is why, for the project, I decided to see if I can build something that will help people to distinguish between benign and malignant moles by just purely looking at the photos or images of this mole. Here is my project in a nutshell. The goal of the project is to build a neural network that can correctly classify cancerous and non-cancerous moles. And for the modeling approach, I will be building a multi-layered convolutional network. Finally, data source is provided by International Skin Imaging Collaboration, which include 2,637 trained images and 660 test images. Dataset is also hosted on a Kaggle during Summer 22 competition. Let's quickly have a look at some of the images available for training. Even from a small sample of 15 pictures, we can see that the color depth, and even the shape vary dramatically between the classes and within one class. So we had a challenging task ahead of us. On this slide, you can see the model that was built. It includes 2 convolutional layers with 64 neurons, same padding and ReLU activation function, followed by max pooling layer and dropout layer with 20% chance of dropping each neuron. Then I flatten it and add another dense layer with 128 neurons, and finally use sigmoid function to produce the output. On the right hand side, you can see the model architecture, noting that we have total of almost 26 million parameters. Finally, I trained the model using binary cross-entropy loss function on 30 epochs and 128 as my mini batch size, leaving 20% of the images available for training for the validation purposes. And as you can see on the plot, my training accuracy reached roughly 80% around 10 epochs and gradually, slowly continued to increase, while my validation accuracy reached maximum of 72.5% at 17th epoch and never reached this high number again. So we will expect probably a prediction accuracy around 72 to 75% in the prediction accuracy phase. With a trained model, I ran a prediction on a test data set, and my convolutional neural network managed to achieve more than 80% prediction accuracy on a never seen images before. Out of 660 images available, 533 were correctly classified as cancerous or non-cancerous, while only 127 pictures were allocated to a wrong group. Taking into account that my model is not very deep, having a more than 80% accuracy quite impressive. These are some of the moles that have been correctly classified. As you can see, they're very different in shape and colors. And that is a sample of incorrectly classified moles. The goal of the project was successfully achieved. I managed to build a convolutional neural network, which consists of 4 layers, and it was trained on more than 2,500 images, and running on a 660 training data set, we achieved more than 80% prediction accuracy. It's a respectful result, taking into account that we had only a local machine at our exposure with 16 GB of RAMs. The result can be improved by adding pre-trained layers or adding data augmentation. Thank you so much for being with me. I hope you enjoyed it.